So hello everyone, today we'll be giving the Leetcode contest of today. So let's start from the last problem. You are given an integer array num, so subarray is called good if the bitwise OR of all its element is equal to at least one element present in that subarray. Return the number of good subarrays in nums. So let's give it an answer equal to 0, equal to instructions. We can maintain a data structure for the range. It would store the XOR value of that particular range and the beginning and end of that range. Should I take a map or unordered map? I don't think hacks are enabled in Leetcode. So let's take unordered map. Sorry, not nums, it's nums of it. Last position of x is equal to I. Okay, it's all right. Feel like I just said XOR. So we are pushing the OR value. Let's take combine value, change value. To this we'll append rx if combine is equal to next. If this is the case, then what are we gonna do? Next toss dot back dot start equal to range dot start. This is when we find the right element here, and if you don't find the right element, like the OR of that value is not present in the next toss, then what are we gonna do? Then we'll do next toss dot push back combine and range dot end. Okay, so this is when we don't find it, and current toss is equal to next toss, and P is greater than or equal to range dot answer plus equal to minimum of P comma range dot start minus 1, sorry, plus 1. This is it. This is where this loop ends. This is where this loop ends. Return answer. Let's see if this works. Okay, let's rename everything. And replace it with current. Next also let's replace it with next. Okay, x is not declared here. What is x here? X was nums of I, right? But we are supposed to be in this loop, right? After doing next dot pushback, where is this loop ending? I guess it's supposed to end here. Let's run this. X. Okay. Lots of bugs here. Minimum of range dot end is it supposed to be 0? No, I guess everything is getting printed as 0. That means this particular thing is not working. What should we do? Should we just debug this? I guess it would take a good amount of time. So what can we do? Let's move to the first question. You're given an array nums1 of n distinct integers. You want to construct another nums2 of length n such that elements in nums2 are either all odd or all even. Okay, so in this version you can subtract nums1 of j from nums1 of I to change its parity. To make all even you need at least two odd numbers, right? You need at least two odd numbers to make all even, to subtract one from another, or zero odd numbers. If there's exactly one odd number, you can't make it even. To make all of them odd, you need at least one odd number to subtract from even numbers. So if there are zero odd numbers, you can't make anything odd. So can I say that it's mathematically impossible for both conditions to fail simultaneously? Therefore, is that even possible? Do you think it's even possible? So, how about just doing a return to? Let's submit this. Huh. Okay, so that takes confidence. No one would expect in the middle of a contest this would work. You are given an array nums1 of n distinct integers. You want to construct another array nums2 of length n such that the elements in nums2 are either all or it's the same problem. You must choose exactly one of the following in any order. Okay, so this is a bit different one. The constraint which we can see here is nums1 of I minus nums2 of j is greater than or equal to 1, means you can only subtract a smaller number from a larger one, right? You can only subtract a smaller number from a larger one. If the absolute minimum of the array is odd, we can make every number odd by subtracting the minimum, right? If the absolute minimum of the array is odd, if the absolute minimum is even, we can never make it odd, okay? Because no smaller number exists to subtract. In this case, only way to succeed is entire array is even. So we need to check for two conditions. Either the entire array is even or the absolute minimum is odd. Then only we can operate on this. So let's take the minimum value as nums1 of 0. Let's take initially all are even. Let us assume that all are even. In this case, update the min value. Min value is equal to x. If x is odd, okay, if x is odd, all even equal to false. Okay, so min value is odd or all even is true, right? This should be the thing. Are we going in the right direction? Let's see. Both should print true. Where is the third test case? True, false, true. Is it printing right? True, false, true. Done. Done. Before this, let's debug that one. Let's write code from start. There's enough amount of time. struct range int value int start int end. This time let's don't forget semicolon and vector range. This was the idea, right? Vector range current was, we have current, we can take unordered map, that doesn't matter. To store the last position for int I equal to 0, I less than I plus plus x equal to nums of I, last of x is equal to I vector range next dot push back. X is the value, I is the start, I is the end. There's only single elements. Then we'll append stuff to it later. Combined would be equal to if it's equal to this, then that means we have found a value and we need to fix the ranges now. Back dot start equal to range dot start. Otherwise expand it further. Let's push combined range dot start range dot end. Okay, that's it, and let's compute the actual contribution now. If last dot count if it's in the map, int p is equal to last of range dot val, p is equal to last of range dot val, and if p is greater than or equal to range dot start answer plus equal to minimum of p comma range and range dot start plus 1. This is it, right? Isn't it? Okay, so let's get out of this and return answer. Current equal to next, both are the same data types, right? No viable overloaded equal to. We can assign vectors like this, obviously. That's how we assign vectors, right? Next is a vector of range. This is a vector of range. Both belong to the same data type. Then what's the problem here? Let's look at third question. Vectors can be assigned like that. Okay, whatever. Let's look at it later. But for now, you are given an integer array nums and an integer target. You may remove any number of elements from nums, possibly 0. Return the minimum number of removals required so that bitwise OR of the remaining elements is equal to target. If it's impossible to achieve target, return -1. If it's impossible to achieve target, return -1. So you may remove any number of elements from nums so that bitwise OR of the remaining elements is equal to target. Is this thing? You can pick any subset from it. You can pick any subset from it. And you need to you need to pick the largest subset whose ZOR is equal to target. This is what we should do, right? So this can be easily done in dynamic programming approach. Okay, so if it has ZOR 0, then its size could be 0. Let's iterate over nums. Let's keep it nw equal to dp. ZOR value and size. After appending the element, size would grow by 1. New of nx is equal to max of new dp of new x. We just had this unordered map for fast lookup so that we could do this. Otherwise, we would have to iterate over it, which would be unnecessary if it was a vector. And it's also sparse, right? So it makes sense. ZOR values could be sparse. That's it. Nums dot hopefully should work. Okay, it's not. We are habituated to typing m and mx for maximum and minimum. So this should be 1, minus 1 and 0. Let's see what this does. 1, minus 1 and 0. Submit. Accepted. Now we are only left with this fourth question, which is really irritating at this moment. You are given an integer array nums. What's the problem here last time? Current equal to next. Why can't I do this? No variable overloaded. Can I do that in the previous way? Move. What's the problem here? Should be current equal to nxt. Okay, that's the problem. I guess I wrote it next before. Is it working? 4, 6. Done. Let's run this. Sorry, we have already done this. Why am I running this? Let's submit this. Done. Okay, so today's Leetcode contest is completely done, guys. Thanks for watching.